In this video, I'm going to explain the main differences between the scalar and vector quantities. Imagine you're hiking in a forest or something, and you got your beautiful map with you. By looking at the map, you figure out that you are 3 kilometers away from the main camp. And that is the scalar quantity. It only tells you the magnitude or the value, which is 3 kilometers, or how far you are from your destination, but it never tells you the direction. On the other hand, if you just pulled up your compass or your mobile phone that has the GPS turned on, it tells you that you are 3 kilometers away east. This time it mentioned direction, and this is the vector quantity because it includes both the magnitude, which is 3 kilometers, and the direction, which is east. Scalars are simple. They only have a size or a value like distance, time, or even speed. While vectors are a bit more detailed because they tell you how much in which direction, like displacement, and we made a video explaining the main differences between the distance and displacement. Also the velocity and force. These are the examples for vector quantities, and these are examples for the scalar quantities. There are more, of course, but yeah, we're gonna know more later on. So if you only know the distance but didn't know the direction, you could end up walking the wrong way and getting more lost. But with the vector, you know exactly where to go, and that's the power of combining magnitude with the direction. In another scenario, we got a soccer player and he kicked the ball straight up into the air. And you can measure how high it goes, let's say 5 meters, and that's a scalar because it's just the height or the distance. But if you throw the ball at a specific angle, let's say 30 degrees, 5 meters into the air, you've got a vector quantity because it has both the distance and the direction. And this is how physicists calculate the motion of objects in sports and games. So as we said, scalar is identified only by the magnitude, while vector is identified by both the magnitude and the direction. And examples on the scalar quantity, as we said, distance, time, mass, density, etc. For vector, we got displacement, weight, velocity, force, etc. I will leave a list of the most common scalar quantities and vectors down in the description so you can check it out when you want to.